Okay guys, 10.3 examples using theorems 3 and 4, at least on our circle wheel, the way we're drawing it up and the way we're writing it in our class. Anyone else, this is all about arcs and chords being congruent to each other. First three examples are exactly that. Then the second two examples are a little bit different. The first example here starts us off by saying we clearly have a chord here that's congruent to a chord over here. That was actually the have I say given information, right? I don't want to say it that way to scare us off. Bottom line, this chord's congruent to that chord, and that tells us with this theorem that this arc that is made by WS and this arc that is created by V and T are also congruent. I would put little tick marks or something, but technically we don't do that there. Basically, we just need to recognize congruent chords here create congruent arcs. And if we're going to write that guy out to solve it, we're going to write 9n minus 11 is equal to 7n plus 11. We subtract our 7n and solve this guy all over the place. We get 2n minus 11 equals 11. Add your 11. We get 2n equals 22, divide n equals 11. Substitute your 11 back in, so 7 times 11 plus 11 gives you 88. It should do the same thing over here, 9 times 11 minus 11, if you write it all out, gives you 88 also. So we find out that our arc up here 88 degrees. And for that matter, VT, 88 degrees. I'm not just blindly writing that, I actually set it up and solved it. Next one we have here is this angle WCS. I know it's not on there, but if we were to create one, we could do so. WCS. And this goes back a few sections on our circle wheel and back to an earlier section in the chapter that tells us if this angle here is a central angle coming out of the center, the vertex here, whatever this arc is, that angle is the same thing, and vice versa. So for that matter, this arc is 88 degrees, this angle is 88 degrees. It's really that simple on that one. And then the last but not least here, segment WS, that's just us making a clear point. You see you have no numbers here for WS or VT, then we don't know how long WS is. It is definitely not 88 degrees. These are not related that way. We just don't know what it is, so we're simply going to write CBD. Cannot be determined. Alright, this guy employs all of that. So first thing here, we'll just read that information. Circle C is congruent to circle J. So we have that circle C and circle J. We have the measurement of GCD congruent to NJM and JM, and that's marked after all. We have these little arc marks here telling us that they're congruent, so we don't really need this, but in case you didn't know what these mean, that's what it's telling us. Our job here is to find NM, and like I mentioned in the first slide, these things are all related. If this angle is congruent to this angle, then this arc is congruent to this arc. And what that's telling us, one last thing then, is that this chord is congruent to this chord. And that does relate back to the previous slide where we gave you congruent chords and you wrote that the arcs were congruent. And I think if you picture this, it kind of makes sense. If this angle is this much and this angle is the same thing, if you want a straight line between these two letters, they're going to be the same. So if we quickly write that guy out, we have 14t minus 26 equals 5t plus 1. Solve that guy all around, subtract our 5t, and we get 9t. I'm shortcutting it here, adding 26 to both sides, we get 27. Divide by 9, trying to save us some time. We get t equals 3. Substituting our 3 back in to t right here, So it's 5 times 3, 15, plus 1 is 16. So our NM is 16. And double checking that real quick, what do we have over here? 14, oop, my bad. We have 14 times 3 minus 26. You do that on your calculator or in your head, you should get 16 as well. Example number 3, clearly nothing's marked on our picture, but we have this given information that says segment AB is congruent to segment BC, which is congruent to segment CD. We all know what that means is we can put our little tick marks on these segments, so that segment's congruent to that segment, which is congruent to that segment. Now it sort of resembles the other examples, where this segment here is congruent to this segment, let's say. It's probably going to mean that this arc is congruent to this arc, and for that matter, obviously also congruent to this arc. So we have 3 arcs that are the same, no matter what they are. Okay, this guy's a little different. A couple different ways of solving it. One way would be to say, hey, you know what? We don't know what these arcs are, and we're asking you about the arcs after all, so why not just make them X? You know, if you don't know what something is, make it an X. Now we just have to add them up, right? X plus X plus X plus 150. Follow me around there. I'm adding up this arc plus this arc plus this arc plus this 150, and I end up back at A again. What do those equal? What would that equal if we go all the way around a circle? 360 degrees. So I add up the 3 x's, and I get 3x plus 150 equals 360. Subtract my 150. This time I'll solve it out so we can all see it a little bit. Cancels out, so I get 3x equals 210 divided by 3. Cancels. X is equal to 70. So this x over here equal to 70. I'll write it there. So this guy's 70 degrees, 70 degrees, and 70 degrees. If you don't believe me, add the 370s up and the 150 and you should get 360. A couple of the things we're asking you for. Arc CD right here. Arc CD, clearly 70 degrees. We're also asking you about major arc ABD. I say major because there's 3 letters and it must be over 180. So let's see. ABD, right? AB, follow the letters D. That's 70 plus 70 plus 70, 210. 210 degrees. Alright, these 2 examples are different. Now we're dealing with this radius or diameter, wouldn't matter, and we have this chord that's crossing it. And what's super important in these 2 examples and any future ones you see is we have this 90-degree box here, that these 2 guys are perpendicular to each other. That leads us to one conclusion, and Miss Fisher's text keeps saying it. Draw a, pausing for dramatic effect, radius. Draw yourself this radius. So now we all have this right triangle. You all know what a right triangle means? Pythagorean Theorem. So I'll write it up here so we don't forget, right? A squared plus B squared equals C squared. Now it's just your job to find out what numbers go where. Well, it looks like we have this guy as 8. We have this NP is 30. I should probably write that down. N to P is 30. Looks like if I break that up a little bit, I find out that, changing colors here, I find out that this guy here is 15, right? Because that's part of our theorem on our circle wheel, is that this segment here and this segment here they're congruent. So if this whole thing is 30, this guy's 15 and this guy's 15. But now I have the 2 sides that I need. And it says SM is what we're finding. So we're actually looking for this little guy here. This is kind of a tricky one. We're actually going to need to put an X here and then use our Pythagorean theorem, our 8 and our 15, to find x. That'll make sense here as we do it. So we'll have 8 squared plus 15 squared equals c squared. So I get what, 64 plus 225 equals c squared. Add those two guys up and we get what, 289. 289 c squared. Don't forget now to take the square roots of those cancel. We end up with a c only. What's the square root of 289? 17. Cool. All that just told us was that this guy over here is 17. So you're looking for SM. You now know that this whole thing here, RM, is 17, right? Isn't this the same as this? Guys, that's a hard thing we miss, man. This radius is the same as this radius. 17 here, 17 here. So 17 minus 8 tells us that SM is 9. This little bit right here is 9. I'm sure you can verify that. 9 plus 8 is 17. We just found out that this side is 17. They match. They better match. They're both a radius. Alright, last example for me. I'm noticing I have a diameter here. I have this chord going across and that they're perpendicular to each other with the 90 degrees. That tells me right off the bat I better draw out of the center and over to this guy here, right triangle. It doesn't matter. You could have went from the C to the B over this way. Either way would work. But I got my right triangle drawn. Looks like I got to find out some of my side lengths. That way I can use my Pythagorean Theorem. I'm going to say, well, this is 6, and this is the same thing, just turned a different way. Right? Comes out of the center, goes to the edge. Comes out of the center, goes to the edge. So that means this guy is 6. Cool. Then I'm going to notice that, well, if this guy is 6, so is this guy. And if we're telling you this much of it is 4, wouldn't that mean that this little bit here is 2, right? 2 plus 4 gives you the 6 that this whole thing is, just like that whole thing over there. So that's going to tell me that this guy here is 2. And I have to look at that. I have 2 of my sides already, right there, ready to go. I have this side here, this side here. I'm going to be looking for this guy down here. You know what? Another trick to that is, it does say find AB after all up here. So that must mean we actually have no idea what any of this is. So you should have realized, I hope, I guess, that this is going to be our x right off the bat. We don't know what it is. Alright, so doing our Pythagorean Theorem, we're going to have x squared plus 2 squared equals 6 squared. Remember, the 6 is our hypotenuse. It's across from the 90 degrees here. It has to be our C. It has to be. Always have to solve it that way. So we have x squared plus 4 equals 36. Subtract 4. Ooh, that's not a very good subtracting 4, is it? Subtract 4 goes away. I have x squared equals 32. Yes, we're allowing decimals now. Somewhat. We shouldn't be doing decimals, but let's see. Take the square root of this guy, and if you do it the proper way, we take 32 and we reduce it down and we get 16 times 2. That's how you get 32, right? Cross off the 16, pull out the 4, and our answer is 4 radical 2. And that's just this guy here. If that's this guy over here also, our final answer of AB is 8 radical 2. That's that whole multiply inside and outside the house thing. The 2's don't change, but the 4's get added together.